Hello friends, Assalamu alaikum. My name is Sayyida Humaira Mehboob and my today's video is all about uniform distribution. The uniform distribution is a continuous probability distribution and is concerned with events that are equally likely to occur. The probability is constant since each variable has an equal chance of being the outcome. Uniform distribution, as its name implies, it functions. If we speak about the amplitude in this graph, so the amplitude is remain constant, or we call the amplitude is remain uniform between the points A and B. These are some formula of density function, variance and mean of uniform distribution. Uniform distribution can be grouped into two categories based on the type of possible outcomes: discrete uniform distribution and continuous uniform distribution. Guys, first we talk about the discrete uniform distribution. A discrete uniform distribution is probability distribution where the probability of outcomes is equally likely and with finite values. As in discrete uniform distribution, there is a probability mass function equal to 1 upon n. Here, n is also always greater than 0. A good example of discrete uniform distribution would be the possible outcome of rolling a six-sided die. The possible value would be 1, 2, 3, 4, 5 or 6. In this case, each of the 6 members has an equal chance of appearing. Therefore, each time the six-sided die is thrown, each side has a chance of 1 upon 6 or 16.7% probability. This 1 upon 6 or 16.7 probability comes by this formula, the formula of probability mass function. Now guys, we are moving towards our second type, which is continuous uniform distribution. A continuous uniform distribution is a probability distribution with an infinite number of equally likely measurable values. A continuous uniform distribution, also referred as rectangular distribution, because it usually comes in rectangular shape. A good example of continuous uniform distribution is an idealized random number generator. However, there is an infinite number of points that can exist. As you see in this graph, there are infinite number or uncountable number exists between the point A to the point B. Now we are moving towards our first example of uniform distribution. The question says that a daily sale of gasoline is uniformly distributed between 2,000 and 5,000 gallons. Find the probability that sales are between 2,500 to 3,000 gallons. More than 4,000 gallons? Exactly 2,500 gallons. For this example, the value of density function always remains same for all three parts, because there will be no variation in y-axis value. The value of y-axis is always consistent, but the value on x-axis are varying. In our first part, we have to find the probability between 2,500 to 3,000 gallons. For finding this probability, we are going to use the formula that is based into height. As we are bounded to find the probability between 2,500 to 3,000 gallons, so the base is between 3,000 to 2,500. Now, for the base, we minus 3,000 with 2,500 and multiplying 1 upon 3,000, result is 16.666%. part B, the same formula is of probability is applying with the difference in base. Now the base is 5000 minus 4000, because we have already asked that in this part we have to find the probability more than 4000 gallons. So the base is 5000 minus 4000 multiplied with the height 1 upon 3000, resulting 33.33% probability. Part C, we have to find the probability exactly at 2500. Here the base is 2500 minus 2500, because we have to find the probability at a single point. So the base is 0 multiplying 1 upon 3000, resulting in probability. So the probability exactly at 2500 is 0. Thank you for watching the video.